Dear student, in previous video, I discussed about the carbon nitrogen and carbon oxygen disconnection. Now in this video, I am going to share with you the retrosynthesis of heterocyclic compounds. Now these are the some features which we have to follow as a strategy during the disconnection of heterocyclic compound. So disconnect carbon heteroatom bond. Disconnect bond in the direction of heteroatom as it is more electronegative. So this two strategy, you always keep it in mind. Heterocyclic compounds are those that heteroatom is a part of a ring compound. So we call these compounds are heterocyclic compounds. Let us discuss the first example. Now this in this example, as nitrogen is a part of a ring, therefore I define this molecule as a heterocyclic compound. So whenever a heterocyclic compound is there, the best disconnection is always either you disconnect a carbon nitrogen bond here, or we can disconnect a carbon nitrogen bond here. But as one more functional group is here, so the best disconnection is here. So carbon nitrogen, this disconnection is best rather than this. So this is the wrong disconnection, the possible disconnection only here. So this is the wrong way to disconnect. So whenever a carbon nitrogen, now here there is a carbonyl nitrogen. So you disconnect the carbonyl group and nitrogen. So disconnect the bond in the direction always a heteroatom. So after this disconnection, this carbonyl group carry a positive charge. So after carrying it a positive charge, so what are the different possibilities? Either we can place a X, we can place a COAT group. So here we have written as a ester group. So carbonyl group is a acceptor and ethoxy group act as a leaving group. So after the getting a negative charge on nitrogen, just what you have to do, the best synthetic equivalent of this is just simply write down the hydrogen there. Now one more carbon nitrogen disconnection is here. So after this again you disconnect the bond in this direction. So one more carbon nitrogen disconnection. After the disconnection of this, so you can see the positive charge is generated on the on the alkyl carbon. So whenever a positive charge on alkyl carbon, the best synthetic equivalent for this, just simply write down the leaving group as Br. The remaining part is methylamine. Now, whenever a halogen compound is there, we always go with the FGI. So first you have to do the FGI and Br, that you have to replace it with the OH. So that you do first of all, replace the Br by OH. So after replacing this Br by OH, now you can see this carbonyl group. Next to that, this is a alpha. Next to this one is the beta, and this is a gamma. So overall, it is 1,4-dioxy pattern, but at the same time, it is gamma hydroxy carbonyl compound. So whenever you have a gamma hydroxy carbonyl compound, the best disconnection, no doubt, 1,4-dicarbonyl compound, the best disconnection is always a 2,3. But if it is a gamma hydroxycarbonyl compound, the best disconnection is always in the direction of alpha carbon. So in the direction of alpha carbon, that is the best disconnection, and the alpha carbon is attached to the COAT group. So CH2 minus COAT, the best synthetic equivalent for this, add the control, that is diethyl malonate. So the best synthetic equivalent for this is diethyl malonate. And the remaining part is here, that is OH, CH2 and CH2, that is a positive charge. Another synthone which is generated here is this. So the best synthetic equivalent for this is the epoxide. So how we can show this, that you complete the synthesis of this. This is the task for you. Now this is the new target molecule. In this target molecule, again you look at the target molecule, what are the different things you can see? There is a carbonyl group, this carbonyl group, so many different functional groups are there. But as the nitrogen is a part of a ring compound, therefore I term this is a heterocyclic compound, and whenever a heterocyclic compound is there, always first of all you disconnect the carbon heteroatom disconnection. So carbon heteroatom here, either we go the disconnection with this, so either we disconnect this bond and this bond, as it is a symmetric, so both the bonds we had to disconnect at a time. So after the disconnection of this gives a aniline, and while the remaining part is COAT group and COAT group. So you can see here now the new relation which is generated here, it is 1, 2, 3, 4 and 5. So new relation is generated here, it is 1,5 dicarbonyl compound. So whenever 1,5 dicarbonyl compound is there, the rest is retro-Michael addition reaction. So Michael addition, the best disconnection is either 2, 3 or 3, 4. Now accordingly, now here look at which disconnection is best. So for that, we have to focus on number 2 and number 4. Both are alpha bond. The one which is more substituted in that direction, we have to disconnect. So we had to choose the 3,4 disconnection in the direction of alpha carbon. So that gives diethyl malonate plus the Michael acceptor is always a alpha beta unsaturated carbonyl compound. So this is Michael acceptor and this one is the Michael donor. Now how to get the Michael acceptor? It is nothing but a alpha beta unsaturated carbonyl compound. So alpha beta unsaturated carbonyl disconnect here. Remember, don't go here aldol condensation reaction. The reason is here there is a presence of ester group. If it is a simple carbonyl group, then you go with the either carbonyl of ketone or carbonyl of aldehyde. Then you can go with the retro aldol condensation reaction. But if there is a ester group, just you simply correlate it with the alpha beta unsaturated carbonyl compound. So beta carbon, this is the alpha carbon and this one is the beta carbon. On the beta carbon, you write on the carbonyl group and alpha carbon is a donor. So donor, as only one of the ester group is there. So we have to add the control and make it as a diethyl malonate. So yeah, that you have to write here, add control. So start the synthesis, look at the synthesis, benzaldehyde, which is treated with that is treated with the malonic acid and then undergo esterification. So after esterification, it gives alpha beta unsaturated carbonyl compound. Then it is treated with the diethyl malonate. So here there is a 1,4 Michael addition reaction. Michael addition, we need a mild reaction condition for this. So sodium ethoxide in presence of ethanol. This proton is extracted by the base and then it attack on the. So this is a 1,4 Michael addition reaction. So after 1,4 Michael addition reaction, it gives this compound. After this, now there is a ring closing reaction by using a aniline. So aniline react with this molecule and ethoxy group act as a leaving group. So ring closure takes place and it gives the target molecule. Now this is the new target molecule. What you see in this target molecule, again nitrogen is a part of a ring. So we can consider this is a carbon nitrogen disconnection and at the same time it is as it is a heterocyclic compound. So now the question arises, which carbon nitrogen bond we have to consider first of all. So as the carbon which is attached to the nitrogen, the substituted pattern is different. In one case, that is the more substituted carbon is there, and the other hand, there is less substituted carbon. So with respect to that, we have to consider where we have to disconnect. So you can see this carbon is more substituted carbon, while the another, this carbon is less substituted carbon. So here we have to give the preference to the more substituted carbon. So this bond we have to disconnect in the direction of nitrogen. So after doing this disconnection, that is what? This gives you a NH2 group, and after this disconnection, there is a positive charge on this carbon, and this carbon is what? This carbon is beta carbon. So this is a alpha carbon, and this one is the beta carbon. So whenever a positive charge on beta carbon, the best synthetic equivalent of is simply alpha beta unsaturated carbonyl compound. So this is nothing but this is a donor and this is the acceptor. If you are doing the reaction at fourth position, so it is a retro-Michael addition reaction, that is retro 1,4-Michael addition reaction. Now next one, look at here, that is there is a CH2NH2 group. CH2NH2 group means, so go with the FGI, so write down on arrow FGI. Instead of CH2NH2, you just simply write down the cyano group. So look at here, the cyano group we are going to place over here. Now the next strategy that we have to follow, it is alpha beta unsaturated carbonyl compound. So whenever alpha beta unsaturated carbonyl compound is there, you go with the retro aldol condensation reaction. So after aldol condensation, so this is alpha carbon and this one is the beta carbon. So on the beta carbon, you can see simply place the carbonyl group, and alpha carbon is a donor. So simple, there is a methyl group. Now you look at the numbering 1, 2, 3, 4, 5. It's a 1,5 dicarbonyl compound, or you can also go from this direction. It is 1, 2, 3, 4, 5. So this is, we can consider C triple bond N as a C triple bond O. So we can consider it is a 1,5 difunctionalized group. So by any way, we have a either go with this 1,5-dicarbonyl compound, or you can go with this 1,5-dicarbonyl compound. So which is the, first of all, we consider this 1,5-dicarbonyl compound. If this is the 1,5-dicarbonyl compound, then the best disconnection is always 2, 3 or 3, 4. Now as the 4 is more substituted, so we disconnect here first of all. After the disconnection here, so this part, now this part is what? Alpha beta unsaturated carbonyl compound. So it gives double bond O and this double bond O. So from one side it gives this. The remaining part is, again we have to go with the 1,5 difunctionalized group. So again we have to disconnect the same 3,4 bond in the direction of 4. The reason behind it, it is more substituted. So at the end, again from this side, what you are getting, that is CN, and the double bond is on this, that is a vinyl cyano group it is. So the from this side, so twice we have to go with the 1,5 difunctionalized group. So at the end, what you are getting, CH3, CH2, CH2, CHO, that means 4 carbon, that is butanol. So look at the synthesis, butanol. Now this proton we have to abstract, and as you know, for the Michael reaction, we need a mild reaction condition. So for the mild reaction condition, we cannot extract this base by we cannot extract this proton by using NaOH so rather than that, the enamine route we have to follow. So due to the enamine route, that proton is undergoing a reaction with this. So carbonyl group forming undergoing a reaction with secondary amine, and at the end it gives alpha beta unsaturated amine, that is enamine. Once you get the enamine, that means it is a mild condition. So then you have to treat it with the best synthetic equivalent for the vinyl cyano group is the vinyl ester. So then you have to treat it with the vinyl ester. So after treatment with vinyl ester, so you write down it is 1,4-Michael addition reaction. So after Michael addition reaction, the product is this. Again, this hydrogen is again no more acidic. So again, we had to go with the enamine route. And after the enamine route, then this again undergo 1,4-Michael addition reaction with this. So after again 1,4-Michael addition reaction, the product is this. Now the next step is the ring closure between this. This is the donor carbon. So it attack here, and that goes to COH. So after removal of water molecule, the product is this. Now the next one is what we had to do. We had to go for the reduction of this COCH3 group. So for that, before that, we have to protect this carbonyl group because this carbonyl group is also susceptible for the reduction. So rather than that, what we have to do first of all to go for the protection of this carbonyl group by using 1,2-diol in presence of paratoluene sulfonic acid. So that undergo protection. So after once it undergo protection, then it is treated with what? Ammonium hydroxide. So ester group is converted to amide functional group, CONH2 group. After that, the carbonyl group is reduced by the lithium aluminum hydride and it gives CH2NH2. After getting CH2NH2, then we have to use the basic reaction condition, and now this attack on this, that is again a one more Michael addition reaction and the ring get closed. So that gives the target molecule. Now this is the new target molecule. Look at in this target molecule, so many things are there in this target molecule. A carbon oxygen linking is there, a carbon nitrogen linking is there. Here also there is a carbon nitrogen linking. So on which first of all we have to focus. So you can see this compound, it is a aromatic compound. So we are not going to disconnect that one. So it is benzopyrrole. We are not going to disconnect. So we just going to put that as AR. So as you know, this is a electron transfer its electron density to this position. Therefore, this is the electron rich position. So electrophilic substitution takes place at this third position. Now the next one where we have to focus. So again, the nitrogen is a part of a ring. So we can call this is a heterocyclic ring. Now, in this heterocyclic ring, now what we have to ask to this nitrogen, it is primary, secondary, or tertiary. So, answer for this is a tertiary nitrogen. Whenever a tertiary nitrogen is there, always go with the FGI and simply you write down the carbonyl group. So, as it is a heterocyclic compound, so no, don't write the carbonyl group here. So, don't write the carbonyl group. You just simply write down the carbonyl group in the ring. So after putting the carbonyl group here, then you disconnect the carbon nitrogen bond and then that gives this compound. So COX. X can be a ester or X can be a halogen. Now, again, this is a secondary amine. So this is what? Secondary amine. Again, we have to go with the FGI. So FGI for secondary amine, again, you have to place the carbonyl group here. So place the carbonyl group and disconnect the bond in the direction of nitrogen. So carbon nitrogen disconnection, it gives COX plus the remaining is ArCH2, CH2, NH2. And this retro we already discussed how we go with this. That is again FGI. FGI is ArCH2, So CH2NH2, this group we have to replace it with the cyno group. So it gives ArCH2 Cn. And again, ArCH2Cn is what? ArCH2Cn. So next step, we have to disconnect this in the direction of cyno. So it gives ArCH2Cl. And what is the next retro of ArCH2Cl? It is simply ArH plus formaldehyde in presence of HCl. So that retro you have to complete it. Now look at this synthesis. So look at the synthesis that ArCH2CH2NH2 plus this, we already discussed the retro of this when we are going to consider with the carbon oxygen disconnection. So this target molecule we already discussed in previous example. So this is the donor. So this is the branch point. So you can go through that target molecule. We already discussed this target molecule in previous video. Now, after doing a reaction with this, the cyclization takes place. Then we have to reduce the carbonyl group to CH2. So that for that we have to use the lithium aluminum hydride, and that gives the target molecule. Now this is the new target molecule. Again, the same thing is that nitrogen is a part of a ring. So we have to focus on the heterocyclic compound strategy. And here there are the carbon nitrogen disconnection. Either we disconnect this bond or this bond. But the best disconnection, as the another functional group is present over here, so the best for disconnection is this in the direction of nitrogen atom. So after the disconnection here, this carbon, there is a positive charge means X is replaced by OH, and that OH is enolic OH, so that reorganize it changes to carbonyl group. So you complete this in a detailed way. After this, what you are getting, so this is simply a donor nitrogen attack on this, and this undergo changes. So once you get this, then remove the water molecule. After removal of water molecule, there is a generation of positive charge, or there is a formation of a quaternary salt. Then the next proton which undergo, that is, we call it is a proton exchange, and hence that gives the target molecule. Now here, again the same situation. Nitrogen is a part of a ring, so it is a heterocyclic compound. So as it is a symmetric, so you both the bonds you disconnect at a time. So it gives what? That gives the methyl amine, and then two carbon nitrogen disconnection. So from this side there is a keto group, that is a carbonyl group here, and same here there is a aldehyde functional group. Now this is a 1,5-dicarbonyl compound. Whenever a 1,5-dicarbonyl compound is there, then there is a retro-Michael addition reaction. So in Michael addition reaction, if you number it from this side, then this is number 2, 3, and 4. This is 5. So best disconnection is either 2, 3 or 3, 4. But here the best disconnection is 3, 4. The reason behind is 4 is more substituted as compared to the number 2. So disconnect in the direction of 4, and the 4 is methyl acetoacetate, plus this side is the Michael acceptor, and Michael acceptor is always a alpha beta unsaturated carbonyl compound, and this is the this proton is flanked by, this hydrogen is flanked by two carbonyl groups. So already Michael reaction, we need a mild reaction condition, therefore that we can achieve, because that hydrogen is flanked by two carbonyl group. Now this is the next retro of this is, it is nothing but alpha beta unsaturated carbonyl compound. So we can go with the retro aldol condensation reaction. So retro aldol condensation, you disconnect here, that is benzaldehyde plus acetaldehyde in presence of NOH. Look at the synthesis, that is methyl acetoacetate, treat it with methyl amine. After treatment with this, it attack on this carbonyl group, this changes to O minus, and then there is a removal of water molecule. And after that, it attacks on the alpha beta unsaturated carbonyl compound, so it gives the final target molecule. Now, the next target molecule is this, that is a substituted furan. Now, which we have to disconnect, the same, both the carbon oxygen bonds we had to disconnect like this, so that at both the side you write down the carbonyl group. So carbonyl group here, carbonyl group here. Now this relation is 1,4-dicarbonyl compound. Whenever 1,4-dicarbonyl compound is there, the best disconnection is always a 2,3 disconnection. Now the question arises here, in the direction of 2 or in the direction of 3. The reason 2 and 3 number are alpha carbon atom. But here you can see that this is the known one, that is ethyl acetoacetate. We can get it from this. So the best disconnection in the direction of 3. So you disconnect in the direction of 3, that gives PaCOCH2Cl plus ethyl acetoacetate. So complete the reaction. So ethyl acetoacetate, treat it with sodium methoxide in presence of ethanol, and then attack it on this. So how to get this compound? These compounds are obtained by acetophenone So treat the acetophenone with acid catalyzed halogenation. So H plus plus X2. So this is acid catalyzed halogenation of acetophenone. So after this, you don't want this ester group. So you hydrolyze it and then decarboxylate it. After this, the compound that we are getting, it's a 1,4-dicarbonyl compound. And the next step is simple acid catalyzed reaction. That due to acid catalyzed reaction, the ring is going to close by this way. So it abstracts the proton and the ring is going to close. That we call it is a formation of furan. Now this is the new target molecule. In this target molecule, what are the different things you can see? There is a nitrogen-nitrogen bond, nitrogen-carbon bond is there. Remember always, nitrogen-nitrogen bond is there. So then you don't disconnect the bond between nitrogen-nitrogen because nitrogen-nitrogen that can be easy. One is the hydrazine. So don't disconnect the bond between nitrogen-nitrogen. So rather than that, the best disconnection here is now you disconnect a carbon nitrogen, this bond in the direction of nitrogen, same this bond in the direction of nitrogen. So what it gives, this side is COAT group and the other side is simple double bond O. So this is nothing but the ethyl acetoacetate plus hydrazine. So you complete the reaction, hydrazine plus ethyl acetoacetate. So cyclization takes place and that gives the target molecule. So you go through the same book. Already these examples are given in this book. So for better understanding, you also refer this book.